Today, IoT devices have become a very integral part of all our businesses and lives. And as the number of devices, IoT devices keeps on increasing, more and more decisions that are being made from the data that these devices produce are getting automated. Now, with this, the challenge that comes is how do we ensure that all these devices that are connected to the cloud are actually can be trusted. Hello everyone, I am Arijit and welcome back to my channel. So today we are going to discuss about a very widely popular technique that is used in IoT space to ensure whether a device, an IoT device, is trustworthy or not. Now today, as devices are becoming more complex and they're having lot of code, it becomes inevitable to avoid the security vulnerabilities that comes in along with the device. And hence there is always a requirement that we need to verify a device. Now we being the cloud service, so the cloud service needs to verify whether the device can be trusted or not before it sets up the communication channel. So with this problem statement in mind comes the idea of device attestation. So today we are going to discuss on what is device attestation. So what is device attestation? So before we go into device attestation, let us understand what is attestation. So at some point in time, each one of us would have got a requirement or an ask to get a government document attested. So what did we do in such scenarios? We went to a notary, we produced a photocopy of the document along with the original. The notary verified the original document with the photocopy and then gave a signature saying that okay, this document is verified. So what did he do? See, basically he verified, he gave a official verification of something that is true or authentic. Similarly, for device attestation is just a mechanism by which we enable a cloud provider to trust a device. So whenever a device, let's say a security webcam, gets connected to a cloud, it continuously sends in video feeds to the cloud. Now a cloud provider needs to verify that the packet that the device is sending is actually trustworthy and doesn't contain any malware or virus. So device attestation is just a mechanism which will enable the cloud provider to trust the device, which is basically making claims about its status or passing in various device information. Okay, so moving on, let's discuss about what are the various uses of device attestation. So as we already discussed, device attestation is used to verify the identity of a device. And also, in case a device, right, while getting onboarded is tampered, or let's say the OS or the software installed in the device is not updated, device attestation can detect all those use cases. Device attestation is also used to send in the various characteristics of the state of the device. Like for instance, the device identity and the manufacturer details, the software version that is installed in the device, at what location the device has been installed. So all these information are nothing but the claims of the device. So all the claims of the device can be sent via device attestation. It is also used to manage the device lifecycle. So till now we have discussed about device attestation. Now let's talk about what is Entity Attestation Token, what we call as EAT. Now what is entity? Now the device or any submodule of the device that is capable of generating its own EAT can be called as an entity. So the attestation basically that the module or the device does should be cryptographically verifiable by the EAT consumer. So we'll come to these details. So entity, as of now, we can say that it is basically the device or any device module that is capable of generating a EAT token. So what is EAT? So EAT is nothing but a set of device claims. By claims I mean the various information that belongs to a device. So whenever the set of claims are cryptographically signed, that is attested, the token that is generated is called the Entity Attestation Token. Now this EAT or the EAT is self-contained and it has absolutely no dependency on the protocol like HTTP, TCP, and so on. And the structure of the EAT token is either JWT or CWT. Now, like most of us are aware of what is JWT, JSON Web Token, right? Similarly, CWT is a CBOR Web Token. So whenever the data is encoded in the form of CBOR or COS, like signing of a CBOR encoded data, the token that gets generated is called a CWT. So on the right side of the diagram, if you see, right, this is a Entity Attestation Token. So all these separate lines are examples of a device claim. That is the information, piece of information about the device. So like the device ID, like the serial number of the device, a nonce can also be passed. So all these are basically a claim of the device. So all these claims are cryptographically secured by signing with the device's private key, and the token that gets generated via that process is called the EAT, Entity Attestation Token. Moving on, let's discuss about how does device attestation actually work. How does the overall architecture or the flow of data looks like. So for device attestation, if you see, there are three major components. One is the entity manufacturer or the OEM, which is actually responsible for manufacturing a device. The second is the device or the entity. So a device can either be an entity or a device can have multiple entities like the submodules, which can be called entity. Now the entity is nothing but a component, as we discussed. It can be used to create a EAT token. And the third is the relying party. Relying party is nothing but the cloud service which needs to verify this device, whether the device is a trusted device or not, before doing any packet exchange. Now if we go over the sequence of the process, the OEM or the entity manufacturer using a key gen creates a key pair, a public key and a private key. Now this private key is handed over to the device during the manufacturing process and is kept in a secure location of the device. Now, and this public key, right, that was created, that can either be managed by the manufacturer in its own key vault or a location where the key can be kept, or it can be handed over to a relying party. Any of this works. So if it is handed over to the relying party is responsible for managing this key. Now, before going into this flow, let's consider relying party let's consider that the relying party or the device wants to fetch some information from the relying party. Let's say it does a get call. Now, before the relying party hands over the information to the device, it needs actually to verify whether this device is a trusted device or not. So in that scenario, what happens is, instead of the relying party handing over the response for the get, it gives back a nonce as a response. The nonce is nothing but a random string, which is actually used to prevent replay attacks. So this is for freshness. So this nonce goes to the device. Now what it does, it collects all the claims and also the nonce that it gets from the relying party, creates a payload, signs it using a private signing key, and creates a EAT token. Now the EAT token has all the claims that are CBOR encrypted and the signature which is COS encrypted. Sorry, CBOR encoded and the signature that is COS encrypted. Now this EAT token is sent to the relying party. Now the relying party has to verify whether the EAT token is coming from a trusted device or not. So what it does, using the EAT token and the public verification key, right, which the manufacturer had created, it uses this public verification key to verify the EAT token. If it sees that the signature matches, it says that okay, this EAT token has come from a trusted device. And after that, it either goes on and processes all the claims of the device information that came and uses it for the further processing, or what it does is, the get call that the device initially did to fetch information from the relying party or the cloud, it gives back the response to that information, because now the device is successfully trusted. So this is how the device attestation actually works. I hope I was able to explain the device attestation process. Please feel free to put in your suggestions or comments. I hope you liked the video. Will request you to share this video and subscribe to my channel. Thank you.